E2B7 says, imagine that you have a sphere 4 centimeters in diameter with a uniformly distributed charge of 33 nanocoulombs. What is the potential in volts 5 centimeters from its center? What is E there? Okay, so here's our sphere. We know that the radius is equal to 4 centimeters. Our charge, Q, is evenly distributed, and that is going to be 33 nanocoulombs. And so that's equal to 33 times 10 to the minus 9 coulombs. And we want to know what is the potential at a point P. And P, so P is at location 5, R is, well, I guess, yeah, R is equal to 5. So 5 centimeters from the center. So that's the location of P. And so now we want to find the potential. So phi is equal to KQ over R. And remember, we learned that from the shell theorem, that we can treat our sphere as if it's a point charge as long as we're outside of the sphere. So if they had asked us what the potential is at if P, our point of interest, was inside, was say at 3 centimeters, then we can say our potential, or phi, is equal to 0. But in this case, we're looking outside of the sphere, so we use KQ over R. So we'll plug numbers in, and we get 9 times 10 to the 9th Newton meters squared per coulomb squared, times 33 times 10 to the minus 9 coulombs, divided by 0.05 meters. And when we plug the numbers in, phi is equal to 5,900. Now let's look at our units. We have newtons meters squared over coulomb squared. All right, so I end up with my coulomb here cancels with one of these. One of my meters here cancels with meters. So I'm left with newtons times meters divided by coulomb. Okay, and I know that a joule, so a joule is equal to a newton times a meter. So here I have a joule, so newton meters are equal to joules over coulomb. And I also know that a joule per coulomb, or a joule divided by a coulomb, is equal to a volt, right? Because that's the definition of potential. Potential is the amount of energy in per charge. So my answer is 5,900 volts. Okay, in order to calculate the electric field at point P due to this sphere, we're going to say E is equal to KQ over RPC squared in the RPC direction. Okay, so what is RPC? And that's just the vector RP minus RC. But we know that RC is at 0, right? We treat our charge as if it's centered at the center of the sphere, and we're assuming that that is our origin. And so we just have RP here. So we have E is equal to 9 times 10 to the 9th Newton meters squared per coulomb squared times 33 times 10 to the minus 9 coulombs divided by, now our R is equal to 5, so 0.05 meters squared. And so when we work that out, we get our meters here squared, cancel, our charge, one of our charges cancels, and we're left with 120,000 newtons per coulomb.